Hi, I'm Mackenzie Costin, a research associate with the microscopy team at the Allen Institute for Cell Science. Today I'm going to demonstrate the Illumination short-term stability measurements as created by the QUAREP-LiMi working group. I will be using an ArgoPOWER HM slide as well as the associated daybook software, which is downloaded onto our acquisition PC. We will also need a spare USB port on this PC. I will be using a ZEISS confocal spinning disk microscope with a 10x error objective. It is important that we turn on our lasers for at least 1 hour before running our illumination methods so that our system, microscope, and lasers are warmed up. We are going to open our Daybook 3 software, launch analysis, which will prompt us to download and upload a calibration file. This file can be downloaded from the ARGOLIGHT website and saved onto your desktop for easy access. I will then go retrieve our ArgoPOWER slide. The ArgoPOWER HM slide requires some assembly before it can be used on our system. We want to plug the USB into the spare USB port on our acquisition PC. We also want to make sure we handle the ArgoPOWER HM measurement slide with care. There are two sides to the ArgoPOWER HM slide. We want to make sure the target is facing up and the sensor is facing down. We use a stage holder insert in order to keep the ArgoPOWER HM slide stable and secure during our measurements. Once our slide is stable and secure, we can verify that our slide is centered. We want to turn on our bright field transmitted light and make sure that it lines up with the target as it is facing up in the slide holder. We can then continue on with our laser measurements. We can open the power meter tab and assess a few parameters over in the left-hand panel. We want to check our COM port number is autofilled, which indicates that our ArgoPOWER slide has been picked up by the computer. We want to enter our excitation wavelength to match the wavelength of the laser that we are going to measure. And we want to make sure our sampling period is 1 second, such that we measure laser power every 1 second. We also want to check our power instruction field. This is going to match the instruction that we give the Microscope software, in our case ZenBlue, so that when we save our data or add a value, the associated power measurement has an indicated power instruction as well. I'm then going to go back to my Microscope software, open my laser bench so that I have access to all of my lasers. In this case, we are just using and measuring the 488 laser. And I'm going to turn on my laser and then start my power measurement. We first want to check to make sure that our ArgoPOWER slide is picking up laser measurement. So we test sliding the power instruction up and down to see the associated jump in the measured optical power. We are also going to set 0. And after we've set 0, we can stop, enter the proper acquisition duration, which for the short-term measurement is only 5 minutes. We will enter the proper power instruction, which is 5%. We are ready to run our power measurement. I suggest you have a book or perhaps a good podcast, some good music to listen to while you run these measurements, as you will be doing 5 minutes for 3 different laser powers for all of your lasers. We will then stop our laser and save our data. You can name your data anything you'd like, preferably something descriptive. We can click Open Results folder and then Power Meter to find the two output files. One can be opened as a CSV and contains all the power measurements, and the other is the graph. We then continue this with our next power instruction, which is 20%, and repeat the process. We will do 5%, 20%, and 80% for all of our lasers. To use and analyze your data, and to calculate illumination stability as a percent variation over time, you can use the following formula, where Pmax and Pmin are the maximal and minimal powers recorded during the time interval measured, and can be found in the CSV data document. For additional information and for full instructions on both the illumination stability measurement and illumination power measurement, please refer to this document, which is on Protocols.io and has been created by the QUAREP-LiMi group. Thank you so much for watching. We hope this has been informative and helps you with your own laser stability measurements.